So we are going to pick up from yesterday. We had just sort of left off yesterday talking about slope-intercept form and what the slope means, how the slope connects to the equation, and how the y-intercept connects to the equation, right? And what we saw was that when something is in the form y equals mx plus b, the m value ends up being the slope, and the b value ends up being the y-intercept on the graph. Okay, and it's really nice because we can use that information to graph. Okay, so you guys had just finished off this one. Some of you guys had finished, some of you hadn't. I think just so that we can review a little bit, let's go through this one together again, and then we will continue. Okay, so graph the linear function with the equation y equals negative 3 over 4x plus 2. Okay, so what's our starting point when we're doing this? Yeah. Yeah, we're going to plot the y-intercept first because we know that that's a point on the line, and that is 2 because that's the b value. Okay, and then how do we get our other points? How do we get the other points once we plot the y-intercept? Yeah.
Like find the slope and then the rise of the run from the graph and then plot points there.
Yeah, so m is negative 3/4. I was going around and talking to some of you individually about this. Sometimes it's easier to think of the slope where you have the negative value either in the numerator or in the denominator. Because remember that the rise and the run, the signs actually tell you about direction, right? So if you have a negative 3 over positive 4, it means you're going down and right. So I'm going down 1, 2, 3, right 1, 2, 3, 4. So there's my next point. Down 3, right 4. There's my next point. Okay? If you think about it this way, positive 3 over negative 4, now you're going up and left. So you're going to get points essentially on the left side of the y-intercept. So I can go up 3, left 4. Up 3, left 4. Okay? And either way, all of these points are going to fall on the line. When I ask you to do this, I want to see very clearly some coordinate points. Okay? So I've sort of drawn dots where those points are. That's what I would want to see. Okay? Let's look at this one, y equals 3x. Okay, so y equals 3x. We are used to sort of seeing things as of yesterday anyway, in this format. Okay, so what is the m value here? What is the b value? Yeah.
The m value is 3 and the b value is 0.
Yeah, b is 0. If you're not adding anything there, you could think of it as plus 0. So that's our first point. I'm actually going to switch colors for this second one. And so I'm going to start there. And then for m, if the m value is 3, if you want to think of that as a rise and a run, you could think of 3 over 1. Or if you want to go in the other direction, you could also think of it this way, negative 3 over negative 1. Okay? Because when you take a negative divided by another negative, you're still going to get positive 3, right? And the only real difference is the direction that the other points are going to go in. Here we're going up 3, right 1. So up 3, right 1. Up 3, right 1. Up 3, right 1. Here, because they're both negative, we go down and left. So down 3, left 1. Down 3, left 1. And then you just get some points on the other side. Okay? And then we connect them. Okay? I want to add one more example here. What if you had something like this? You wanted to graph something like that. Yeah. Exactly. Yeah. So this is not in slope-intercept form. right? When something's in slope-intercept form, we can very clearly see what the slope value is and what the y-intercept is. Now, this is a linear relation, but we don't have y isolated, right? When it's in slope-intercept form, the y variable is isolated. So all we need to do here is a little bit of algebra so that we can isolate the y, okay? So I think what I'll do is
Those students who were invited to the principal advisory meeting, with teacher permission, could you please make your way to the middle of the hub in the resource area for your meeting today? That's those students that were invited. Thank you.
Anyone on the PAC, Principal Advisory? No? Okay. All right, so I'm going to maybe subtract 2x from both sides so that I just have the y term by itself, right? So this goes away and I have negative 3y equals negative 2x plus 12. Okay, and then what would we do to isolate y? Yep.
I was gonna say minus 12, but then the 12 would just be going back and forth.
Yeah, so we've got negative 3y. We just want 1y. Yeah.
Divide by negative 3.
Yeah, divide everything by negative 3. So I'm going to divide this, this, and this by negative 3. And then what I have is, I'll just write it over here maybe. On the left side, I have y. Negative 2 over negative 3 is just 2 over 3. X, and then 12 divided by negative 3 is minus 4. Okay? Yep. Okay, so good question. Do we add 3 instead of dividing? So if it was y minus 3, then you would add. But whenever there's a number and a variable right beside each other with no sign in between, the implied math operation is multiplication. Okay, so what's going on between the y and the negative 3 is they're being multiplied together. Yeah. Okay, so now what we could do is plot that y-intercept at negative 4, and our slope is up to right 3, up to right 3, up to right 3. Or you could go down to left 3, down to left 3. Yeah, but just because something's not in slope-intercept form doesn't mean that we can graph it. We can rearrange things and then graph once it's in slope-intercept form. Okay, so what I'd also like to talk about today is what if we're going in the other direction? What if we have a graph and we want to figure out the equation of the graph? Okay, now, when we are trying to write an equation, all that we need to remember is that we need two values, the slope and the y-intercept. And we can figure those out from the graph. Yep. Yeah, the y-intercept is negative 4, right? So we need y equals mx plus b. All we need to do is identify those two values. So b is negative 4, okay? To get m, pick any 2 points on the graph. You could do this one and this one. You could do this one and this one. I would pick 2 points that like sit on the intersection of the grids because then it's really easy to read their coordinates, right? I could also pick like this one over here, but then I'm sort of approximating what the x and the y value are, okay? And I don't really want to do that. So pick some that are on grid marks, and then you can just use rise over run. So here, to get from here to here, for example, I'm going down 3, right 2, right? Or if you went from here all the way to there, you're going down 6, right 4. But it's still the same value because negative 6 over 4 reduces to negative 3 over 2. So m is rise over run. And here we go down 3, so the rise is negative 3, and then right 2 over 2. Okay? Once you know those two values, you just plop them in. Negative 3 over 2x minus 4. And there's our equation. Okay? Now, we're also asked to verify that this is true. So if we want to check that this is the correct equation, one way that we can do so is pick a point on the graph, pick any x point and figure out the x, y coordinate, and then plug in the x and the y value of that point. If the left side equals the right side, then we probably have the correct equation. Okay? There's one bad choice for a point to pick. Which point do you think that is? Yeah?
The origin of the graph, like this.
Well, the origin isn't a point on the graph, so we don't have the option that point. If the origin was on the graph, yeah, I'd say that's a bad option. But on this particular line, what would be a bad option? Yeah. The Y-intercept, yeah. Don't pick the Y-intercept. Why do you think that is? Yeah.
Because that means x is 0.
Yeah, so x is 0 on the Y-intercept. So if you plug a 0 in here, then if you've made an error in figuring out your slope, you're going to get like a false positive. Okay? So to verify, plug in any point, make sure the left side equals the right side, but don't choose the Y-intercept. Okay? Because then you won't know if you have made a mistake in your slope or not. Okay? So to verify, plug in any point for x and y, but not the Y-intercept. Okay? I'm going to do that over here and show you how I sort of set up verification. Okay? So what I like to do is write out the equation. Okay? And then I kind of do a little chart. So I'm plugging in, let's say I plug in this point over here. That point is -4, 2. Okay? So what I like to do is, okay, this is y, so that's 2. This is -3/2 times x, which is -4 minus 4. Okay? And I know that this left side is equal to 2, so I'm just going to leave that. I don't have to do anything there. But here I have to evaluate this, right? So -3 times -4 is 12/2 minus 4. And that's 6 minus 4, which is 2. I have the left side equal to the right side, right? So I have left side of the equation equals the right side, which is good. I've verified. Okay? What I see a lot is I ask people to verify, and they just plug in the points and they write that they're equal, but they don't actually go through the process of evaluating both sides. And in fact, they're not equal. Okay, so the point of verification is to actually check this. So you actually do have to go through the process of simplifying. What is this equal on the left side? What is this equal on the right side? Are the two sides equal to each other? Okay, because we don't know yet. We can't put an equal sign here yet in the middle because that's what we're trying to check. Okay, so that's how I like to set up verifications. Okay, all right, I'm going to get you guys to try this question here. And then we will talk about some applications. All right. So as I was walking around, I'm noticing that most of you guys are getting the hang of this. There's still a few mistakes with slope. Okay. So I just want to talk about that, right? So to get an equation, you need y-intercept. That's right here at -3. And you need slope, which is rise over run. Be really, really conscious when you're rising and running in which directions you're going. To get from here to here, you go up and right. Up and right are both positive directions. Okay? Down and left are the negative directions. So your slope is up 2 over right 1. Okay? That's 2 over 1, which is just 2. if you go the other way, right, let's say you go from here to here, you're going down and left. Okay, well, down and left are two negative directions. So if you think about it that way, it's -2, because down is negative, over -1. Left is also negative. Well, -2 over -1 equals 2. Okay, so either way you slice it, you should get a slope of 2. Okay, the y-intercept here is -3. So your equation becomes y equals 2x minus 3. Now to verify, pick any point that's on the line, except this guy, right? So you could pick this one. You could pick this one, this one, this one, this one. Any of those points will do. So let's say, I don't know, let's pick this one. This is the point 3, 3. Okay? And what I want to do is plug that point into both sides. So if I'm verifying, I might make like a little chart here and say, okay, my y value is 3, so that goes on this side. My x value is 3, so that's what I'm going to plug in here. And now I have to evaluate this side, right? This side has already been like evaluated. There's nothing more I can do there. But this is 6 minus 3, which is 3. Now I have the left side equaling the right side. That's what I want. Okay? All right. So what I want to do now, any other questions before I move on? I want to actually backtrack and go to this example that I skipped yesterday. Where was it? No, previous page. Here we go. Okay. And this one is an application question. So I want to talk a little bit about this. Okay, a cell phone plan. Now, by the way, this curriculum came in 2010. Okay. I was teaching at Lester B. Pearson at the time. And technology has evolved since then, right? So if it came in 2010, they probably started writing this textbook 2008 or so. Things have evolved since then. The first text message I ever received, I believe, was in 2003. So this was only 5 years after. I'm sure people were texting before that, but I was a little late to the game. No, I'm wrong. It wasn't 2003. It was 2005. I was in third year university. Never mind. Okay, so this was just a couple years later. Okay, so just keep that in mind when we go through this. A cell phone plan charges a monthly fee that covers the cost of the first 300 minutes of phone use. And the graph represents the cost of the plan based on the time beyond 300 minutes. So back in the day, you had to be very conscious of how long you were talking for. Because if you went beyond 300 minutes or whatever the allotted time was, you got charged per minute for any extra time. Okay? So how do you know that this is a graph of a linear function, and what does the slope of the graph represent? Write an equation to describe this function. Okay, well, how do we know it's a linear function? Let's start with that. It's a line, yeah. It makes a line when you graph it. Okay. What does the slope of the line represent? So let's actually figure that out. Let's say we go from this point to this point. I'm going up and I'm going right. Okay. So how much do I go up?
3.
Not 3. Watch the scale. Careful. Yeah, each of these little squares is worth how much? 5. Yeah, so I'm going up 5, 10, 15. My slope is positive 15 over, and then I'm going right. Each of these little squares along the horizontal is worth how much? 10. 10, exactly. So I'm going right 10, 20, 30, 40, 50. Okay? And that becomes, well, in this case, if you think about slope, if we're trying to figure out what does it represent, what I would recommend doing is thinking about this as a rate of change instead of a slope. Because with rate of change, we have to include units, right? And so if we include units, the vertical unit is dollars. So this is $15 per, the horizontal is minutes. 50 minutes. Okay, and in this case, I would actually probably figure out the unit rate. What's the cost per minute here, right? So 15 divided by 50 is 0.3. This is 30 cents per minute.
Wait, so you wouldn't reduce the fraction after
So do you reduce the fraction or not? So the answer to that is it depends on the context. If you're trying to figure out what something means, usually the slope is a rate, right? A rate is something that compares two units. And it's most useful, I would say, to think of the rate as a unit rate. And a unit rate is how much of the dependent per one of the independent. How much per 1 minute? That's what we really want to know, right? If we say, well, it costs you $15 for 50 minutes, it's more useful to actually know it's 30 cents a minute, right? So you have to actually think quite carefully about context when you're doing this. It's not like 15 over 50 is wrong, or you could reduce that to 3 over 20, but is it more useful to think of it as 3 over $20 per minute, or sorry, no,
3 over 10.
3 over 10, thank you. Is it more useful to think of it as 3 over $10 per minute or 30 cents per minute, right? It's the same, but you also, like, think as if you were someone at TELUS answering the phone and I would hate to have that job, but think that you're talking to someone about cell phone plans. Would you say to them, it's going to cost you 3 over $10 per minute? Or would you say 30 cents per minute, right? So they're the same thing, yes, but we have to think about when we're communicating, right? What sort of makes the most sense, right? So, you know, this is a totally different example, but just one that I'm thinking of along the same lines. People will ask me, does the answer have to be an improper fraction or a mixed fraction, right? And I usually say it depends. If you're talking about a recipe and how many cups of flour that you need, you don't usually say that you need 11 over 3 cups of flour in the recipe, right? You'd say it's 3 2/3. So it really depends on context and what you're trying to communicate and what's going to be the easiest for the person on the other end to understand about the context. Okay? So it's a bit gray. I know people don't like that in math, but it is a little bit gray. You have to, you know, it's not like one is more right than the other. It's what makes more sense. Okay? All right, so 30 cents per minute. What's the Y-intercept here? We're going to write an equation. What's the Y-intercept? $20, yeah. So if we write an equation for cost, and this is time for minute, or no, this is n for number of minutes, right? The slope is 0.30 or 0.3 times n plus 20. Okay. What do you think the 20 represents? Yeah. Oh, sorry. Yeah, go ahead, sorry.
The initial cost for the overtime?
Yeah, so this represents 0 on the n-axis, represents the number of extra minutes beyond 300. Okay, so the $20, what's that going to cover? The first 300 minutes, exactly. So this $20 is the first 300 minutes, and then after that we have to pay 30 cents per minute. Okay, that's quite a premium because $20 for 300 minutes, that's less than 10 cents per minute there. It's like, what would it be, about 6.6 cents per minute, and then after you go over, like, you're paying 4 or 5 times as much. That's a lot. Okay, so yeah, we had to really limit our phone calls. And back then, I think why I was thinking about text messages is you got charged per text message, right? So I think the first time I got a text messaging in my phone plan, I had like 20 free text messages a month, and then I had to pay for everyone after that, right? And if I think about the number of text messages that I send and receive these days, it's crazy. I spend way less time talking on the phone though.
Yeah.
Okay. All right, so let's look at another few more examples. Actually, yeah, let's do this first, then we'll track back, okay? All right, so the student council sponsored a dance. A ticket cost $5, and the cost for the DJ was $300. Okay, so if you think you're on student council or student leadership, you're planning a school dance, the entry fee, price of admission is $5, and then you also have to pay for the DJ. You hired a DJ, the DJ costs $300. Okay? All right. Write an equation for profit, P dollars, on the sale of T tickets. Okay, well, if anyone has ever had any sort of business experience before, you might know the difference, and I'm talking about even like a lemonade stand. You might know the difference between profit and revenue. Can anyone explain that to me? What's the difference between profit and revenue? Yeah.
Profit is how much you make after you surpass your original cost.
Mm-hmm. Yeah. Profit is you have how much money you make after you take into account what did you have to pay to actually get this thing running, right? What are your costs? So if, for example, you're running a lemonade stand, and usually you guys, if you remember running remember running a lemonade stand, like my kids have had a lemonade stand, I usually just cover the cost of the lemonade so they don't have to think about this. But in reality, right, you have to pay for either lemon and sugar and that kind of thing, or you can buy the canned mix. There's costs involved, right? So if the canned mix costs $1 a can and it makes 5 glasses of lemonade and you sell each glass for $1, that one can is going to make $5. But you haven't actually made $5 because what did it cost you to make the lemonade?
$5.
No, you make $5 from the people that are buying it. What did you pay for the can? $1. Yeah. So you're actually only making $4. Exactly. Yeah. Exactly.
Instead of like adding the main thing was you would subtract it.
Yeah, so profit equals your revenue. Revenue is the word for how much money are you actually taking in from customers. Minus your costs. And this comes into account in any sort of business, right? Sometimes the costs are pretty cheap if you're running it out of your home or whatnot. Maybe your costs are just, I don't know, like if it's an internet company, it might just be your internet bill or whatever, right? Sometimes they're really steep. If you are running, I don't know, an accounting firm or a law firm or something like that, you have to pay incredibly high rent. You have to pay all of your staff that are working for you. So if you think about how much money are you taking in from clients, right? Or any kind of, you think of physiotherapy or any of these types of offices, they have really big overhead costs. That's called overhead, right? They have to pay for rent, they have to pay for the person at the front desk, all of those sorts of things. So they have to take that all into account when they're trying to consider their profit. How much money do they take into account, take home at the end of the day, okay? All right, so let's write an equation for profit P dollars on the sale of T tickets. So how would we figure out our revenue here? $5 a ticket, we sell T tickets. What's the revenue going to be? Yeah? 5T, exactly. So our profit is going to be, revenue is 5T. And then how much are our costs? Exactly. We got to pay the DJ $300. Exactly. Okay? So suppose 123 people bought tickets. What was the profit? Well, once we know how many people bought tickets, we can just plug that in here, right? So P equals 5 times 123 minus 300, which is, I don't know, what is that? 5 times 123, 615, right? Yeah. Whoops. 615 minus 300. So you make 300, there we go, and $15. Okay? Suppose the profit was $350. how many people attended. How would you figure this one out? Yeah.
You add the 350 on both sides. So
On both sides?
on the left side.
Yeah, so here's the deal. When we're working with these types of relations, this is a really common theme, and it's not just for linear relations, it's for all types of relations. We will give you one of the two variables and ask you to figure out the other one. So once you have an equation, you just have to figure out, do I know T or do I know P? Here we know P. We know the profit was 350, so we're going to plug it in for P on the left. Right? And then we can solve. So we would like add 300 to both sides. And then this is 650 equals 5t. And then we can divide by 5. And I believe that's 130. 130 people. Okay? Question. What if I asked you, how many tickets do you need to sell to break even? If I asked, how many tickets do you need to sell to break even? How would you figure that out? What does it mean to break even? Yeah.
It means that you make how much you paid for.
Exactly.
Then you would find P equals.
Yes, exactly. So when you break even, that's a really good thing to know if you're planning a business or planning an event or something like this. How much do I need to sell so that I don't lose any money, right? Now, if you don't lose any money, but you don't make any money, that means breaking even. Your profit is 0. So we would just put a 0 in here. And I think someone even said what it was. Did someone say 60? If I add 300 to both sides. Right? Yeah. So I have 300 equals 5t. And then when you divide by 5, you get 60. Okay? Yeah, that's a good thing to know because you essentially, like, the worst thing that could happen is that you lose money when you're planning like a school event or something like that. Okay? And if you were, for example, planning a business and you wanted to go to the bank and get a business loan, they would want to see this kind of analysis, right? You want to borrow money for your costs. What do you project your revenue to be? Because we want to make sure we get our money back, kind of thing. All right. So I'm going to get you guys to try this one. And then I actually want to backtrack a little bit and talk about these questions on the graphing calculator as well. So we'll do that too. I want to quickly show you guys some extra features of the graphing calculator. So I was walking around. Everyone's getting the hang of this. You got the equation C equals 29. I'm like trying to think and write at the same time, and obviously I can't do that today. 29n plus 99. Okay, so that's good. Perfect. What I want to show you is some stuff that you can do on the calculator. So take your calculators out. I'm going to take out both of them. And if we wanted to graph this on a calculator, one thing that's really important in these application questions is to think about your domain and range, because that's really going to affect your window setting. Okay, so I'm going to start with this guy, and I'm going to go to y equals, and I'm going to put in 29x plus 99. And I'm going to hit graph. And I really can't see anything useful here. Okay? So let's think about this. C represents a cost, N represents number of people. Is it possible for either of those to be negative? Could you have a negative cost in this case, or negative number of people, or not number of people, number of months? No, neither of those could be negative. So we don't need any of this stuff. Any of the negative x or negative y is useless to us. Okay, so we want essentially our x min and y min to be 0. Now thinking about the cost, what's the starting cost here? If you go for 0 months, 99 bucks. Our maximum, I think my setting right now is at 15. I'm not going to be able to see anything because the minimum cost is 99. So if I really want to take a look at what this is going to look like, I have to go to my window and think, okay, this x represents months. The minimum is 0. Let's say I want to track the cost over 2 years. Then I would make my x max 24. Okay, because that's 24 months is 2 years. Now for my y minimum, I'm going to start that at 0, even though really it starts at 99. It's like nice to see the origin in these graphs. And I don't know what this is going to cost me. It's 29 bucks a month. Let's say just to estimate there were 10 months in a year instead of 12. That's around at least $300 a year. So for 2 years, that's at least $600 plus the 99, that's $700. I'm going to make my y max $1,000. Right? You have to kind of go through that thought process when you're setting your windows. And I'm now going to change my scale because I don't want 1,000 ticks along the vertical. I'm going to make my scale maybe 100. And now I can hit graph. Okay, so I'll do that on the Casio as well. I'm just going to try and make this a little bigger. How did I do this yesterday? I don't know. Anyway, this is really tiny. Hold on, let's see if I can make it bigger. Normal. Will it fit in? Yeah, somewhat. There we go, that's a little better. Okay, so on the Casio, there we go. No, don't do that to me. Okay, that's all right. Okay, so on the Casio, I'm going to delete this. And then I'm going to enter in, again, 29x plus 99. And if I hit draw, again, I don't see much, right? So I'm going to go to my window, and I'm going to make my x min 0, and my x max 24. Okay, the scale is fine. I'm going to make my y min 0 and my y max 1,000 and my y scale 100. Okay, and then I can draw it again. And there we go. That's better. Okay, now the other thing that you can do on these calculators, and I think it said what would it cost for how many months? I can't remember. 23 months or something? What were the questions, you guys? Yeah, so what would it cost for 23 months? Well, 23 months is the X value. So on the TI, if you wanted to use the calculator to do that, you could go second calc and press number 1 for value. Usually we use this to find the Y-intercept, but you could put in whatever X value you want. You could put in X equals 23, and it'll tell you the cost is $766. Tells you the Y value. Yep.
I'm not sure if it works on other calculators.
Yeah?
If you have a TI-84 plus CE, there's a tool called Equation Solver that will do that as well.
Yes. Yeah, some of the calculators have different features for sure. Okay, on this guy, you can go to GSolve again. Now you want to go all the way over here. And what we want is a Y calculation. We want to know what the cost is. So we're going to press F1, and then you can enter in your X value, which is 23. Okay, and it'll give you 766. Now, once I'm on the Casio, I'm going to go back to GSolve again, because the second part of the question asked around what's the number of months for a particular cost, right? What was the cost? Yeah, so you can instead go to what was it? It was, can't remember exactly what it's called. XCalc, yeah. So go to XCalc, we want the value of an X value, put in 505 for the Y value, and it gives you the X value is 14 months, okay? That step is a little bit more complicated on the TI. So on the TI, pretty easy to get the Y value if you know the X value. There is no function, though, to figure out an X value rather if you know the Y value. So there is a workaround. What we can do is we can plot a horizontal line at 505, which is going to be right here, and then find an intersection point, and that will tell us the X value. Okay, so I want to show you how to do that because that is a really common thing that we have to do. All we're going to do is go into Y equals, go down to Y2, and we're going to plot another line. And this line is 505. And then we can hit graph. And essentially, what we want to know is what's the X value on here of the intersection point? Because that will tell us the number of months to reach $505, for the cost to reach $505. So to do that, we're going to go second calc again. That everything that we need is under that menu. And we go down to 5 for intersect. And it's going to ask us, are we close to the intersection point on the first curve? And I'm just going to hit enter. Am I close on the second curve? I'm going to hit enter. Do I want to guess? Yes. And it tells me the X value is 14 months. Okay? So that's just another little feature. Not super important for this particular example because we can very easily figure this out algebraically, but it is nice to know because it can be super handy in other examples. All right, another couple of examples, and then we are going to talk very, very briefly about vertical and horizontal lines, and then we'll call it a day. Okay, so here is one. Does the point -2, 4 fall on the line y equals -4x plus 6? So I gave you a hint here. I probably shouldn't have done that, but if you want to know if a point falls on a line, how would you figure that out? Yeah. Yeah, plug it in, see if the left side's equal to the right side, right? So that's what we're going to do. We're going to plug in for y the value 4 and for x the value -2. This is equal to 4. This is equal to -2 plus, -4 times 2 is 8 plus 6 is 14. Those are not equal to one another. So this point is not on the line. This does not equal 4. Okay, so not on the line. Okay, here's another type of question that you can get. Find k so that the point 5k falls on this line. Okay, well, how do you think you'd figure that out? I want to know what's the y value if this point is on this line. If the point, yep. Yeah, well, you're going to plug in both, actually. Plug in the value 5 for x and the value k for y. You will only have one unknown there. If you have one unknown, you can solve that, okay? So we're just going to plug in and solve. And you can get all sorts of questions like this. You might get a point and a slope, and you want the b value. Or you might get a point and a b value, you want the slope, right? As long as you know sort of 3 out of 4, right? Because if you think about this, there are 4 possible different things that we might know here. An x coordinate, a y coordinate, the slope, and the y-intercept. As long as you know 3 out of 4, you can plug in what you know and figure out the 4th one. Okay? So here we're going to plug in for y, the letter k, and for x we're going to plug in a 5. Okay? Now, 5 over 5, those cancel. So this is just 7 minus 2, which is 5. K equals 5. That's the value of k that would make the left side equal to the right side. Okay? And then we can also phrase it this way. What's h so that h negative 1 falls on this line? Okay, same idea, but now we're plugging in an h for x and a negative 1 for y. So I'm going to put a negative 1 in here and solve that. Okay, now this is going to take a little bit more work because I have to go about isolating h. But we can do that. That's doable. I'm going to maybe start by adding 2 to both sides. We'll get to that. We'll get to that. Okay, so this goes away. On this side, I have 7 over 5h equals negative 1 plus 2 is 1. Okay, now with the fraction, essentially, we have to do both multiplication and division. We have to undo multiplication and division, right? Multiplying by 7, dividing by 5. You can do those in either order or at the same time because multiplication and division are sort of equal along the BEDMAS scale, right? So I'm going to do it in 2 steps just because when you see it for the first time, sometimes it can be hard to do it in one. I'm going to start by undoing the division by 5 by multiplying both sides by 5. Those cancel. And then I have 5 times 1 is 5 equals 7h. And then I can divide both sides by 7. And I get that h equals 5 over 7. Okay? If you wanted to do it in one step, you would just multiply by both sides by 5 over 7. Because 7 over 5 times 5 over 7 is 1. All right. And finally, any questions there? No? Okay. Last thing I just want to review, and we already talked about this on Monday actually, is horizontal and vertical lines. But now we have a little bit more information about slope and y-intercept, so I want to talk about that too. Okay? So how can you use the slope form of the equation y equals mx plus b to graph the horizontal line y equals 2? Well, if we have this line, y equals 2, and we want to think about it in this format, the 2 is actually the b value. So if there's no x term, what would m have to be? 0, yes. And we actually talked about that, right? When you have a horizontal line, the slope is 0 because there's no rise. Now, what does this look like? This looks like, well, actually, I don't have a grid here. A horizontal line at 2. Right? And we talked about that too. Any horizontal line is essentially y equals a number. And that number is going to be wherever the line sits. Okay? Vertical lines. Can we write the vertical line in the form y equals mx plus b? Let's say we have the line x equals 2. Can we write it in the form y equals mx plus b? No, we can't. Okay? The reason for that is that vertical lines are not functions. And the slope-intercept form of a line is actually the slope-intercept form of a linear function, not just a linear relation, right? So we can't do this. We can still draw the line, right? The vertical line x equals 2 is going to be a vertical line right over here. And the reason why it has that equation is that all we really need to know about any point on this line is that horizontally it's at 2. Vertically it can be anywhere, so y doesn't even come into play in the equation. Okay? And we talked about that as well. All vertical lines can be written in the form x equals a number. What's the slope of this line? Yeah, it's undefined, right? Because you have a lot of rise. The rise could be any number, but your run is 0. And any number divided by 0 is undefined. So you may want to just reiterate that. Okay, so here I have this summarized. Horizontal lines have the equation y equals some constant. Vertical lines have the form x equals some constant. So let's say I had this line over here. What would the equation of this horizontal line be? This line over here. What's the equation of that line? Yeah. Exactly. This is y equals -7. And what about this horizontal line? What's the equation of that line? Yep. X equals 4, exactly. Okay. And then if we wanted to graph these two on the same grid, I'm going to let you guys do that. Y equals 8, x equals -1. And that should wrap things up for today. Okay. Before the bell you still have 3 or 4 minutes, so please make sure to do that. We're moving on to the next form of a line on Monday. Okay, so important that you practice this over the weekend. Over here on the board, I sort of kept up the homework from yesterday, and then I've added in these questions for today because we've learned a little bit more. Okay, so please make sure to do some practice over the weekend because it is a lot of information to be taking in, and starting on Monday, we're going to add in even more.